We are Group H student. Here is our group project, which is Fuzhou to Taipei HSR preliminary feasibility study. The whole feasibility study outline, including the project objective, potential HSR line, potential HSR station, conceptual engineering, which including horizontal alignment, vertical alignment, infrastructure type selection, capital cost estimation. The project objective for this feasibility study, which is the motivation. The motivation that we are having is because there is low direct transportation between Taiwan to other city, and that is the initial brainstorming idea to let us to thinking about the possibility to having any HSR between Taiwan to China. And basing on the good example of Eurostar, which between British and France, we can have more and more information for our study. For our preliminary evaluation of this new high-speed railway route between Taipei in Taiwan and Fuzhou in China, and other possible intermediate points. Potential new HL line. According to our study, in Fuzhou to Taipei, this railway, we find that in China, Fuzhou, that link to the other China city, there's a lot of HSR railway. And that is our proposal to having a HSR between Fuzhou to Taipei is because the distance is quite short. We have 4 criteria for this new HSR. The first criteria is for the metropolitan size. The Fuzhou population is around 7 million, which is the largest city in Fujian province. In Taipei, there is 7 million also, and which is the capital in Taiwan. The second criteria is the distance, just what I have mentioned. According to the information from the paper where high-speed railway works best, it stated that the distance, which below 160 km, is better for the normal railway network, and for the distance which above 800 km is better to shoot for the flight. For this distance between Fuzhou to Taipei is around 300 km, and which is we think that is most suitable for HSR railway. For the information, for the HSR speed is normally above 250 km per hour, and for this HSR is around 1 hour. The third criteria is the transition connection. In Fuzhou, we have a lot of connection from Fuzhou to other China city, which including Beijing, Shanghai, Chongqing, a lot of places. You can see from this map. And also inside the Fuzhou, they have their metro connection network. From Taiwan side, that in these few years, the new HSR have been built in Taiwan, which is from the Taipei to Thailand and to the Kaohsiung side. Within Taipei, that is also have a very great and good network. The fourth criteria that we are studying is about the economic productivity. In Fuzhou, that is 6,000 USD dollars for the GDP, and in Taipei, that is 30,000 USD dollar. Just for information, For Shanghai, there's around 10,000 USD dollar for the GDP. So we can see that Fuzhou is also a very good economic city. The next topic, potential location for HSR station.
Well, and in this analysis, we will take two locations in Taipei side and also two locations in China side. In Taiwan side, the first location is Taipei HSR station. As you can see in this picture, it is the traffic is the most. And the second location is Taipei Danshui Metro Station.
The reason that we choose this one and another point because it's near the coastal side, and that's why we think that there may be a possibility to having the high-speed railway station. In Fuzhou side, we are having the two location study. One is the Fuzhou South HSR railway station. From this station, they can linkage to another city in China.
And the last one in China is Fuzhou Wuyi Metro Station. As you can see in this picture, there are so many people around this location. So among these four candidate locations, we can sum up and conclude into four routes. For the first route, it is from the Taipei HSR station to Fuzhou South HSR station. For the route 2 is Taipei Danshui station to Fuzhou South HSR station. And for route 3 is from Taipei HSR station to Fuzhou Wuyi Metro station. And for the last route, it is from Taipei Danshui station to Fuzhou Wuyi Metro station. In order to quantify which route is the best, we propose an assessment method, and here is the assessment methodology. For this methodology, we will consider totally three main aspects. As you can see in this picture, the first one is the economic aspect, which contribute to the most among three aspects, which is 60%. And for the second, it is human factor aspect, which contribute to the 18% of the total. The last one is engineering aspect, which contribute to 22%. Among these three main aspects, we can subdivide this main point into different considerations. For the economic aspect, we will consider the estimated traffic and also the population served. And for each of the sub aspect, we will use some letter to represent it. For example, for the estimated traffic, we'll use ET to represent this factor. And also, for the economic aspect, as you can see, the total contribution is 100%. And as in the same situation, for the human factor aspect, we will assess the accessibility, which contribute to 75%, and also interchange and transfer for 25%. For the third aspect, it is the engineering aspect. We will mainly consider the construction costs for this high-speed railway line. By summarize of the previous page, we can construct some equations in each of the three aspects. For example, for the economic value, we can propose an equation for 60% of ET plus 40% of PS for this equation, and this equation is contribute to 60%. Also, for the human factor value, the equation is 0.75 IT plus 0.25 AC. As the same for engineering value, it is 100% of the construction cost. Therefore, the total cost, the total value of each of the candidate is the weighted average of the above three aspects. So the overall equation is this equation. So by using this equation, and there are 5 different aspects. For each aspect, we will allocate some marks to each of the route, and the maximum mark for each of the aspect is 10 marks. So in this table, you can see for the estimated traffic, Route 3 and Route 1 has a high mark because for the Taipei HSR station, it has higher traffic flow. And for the population served, you can see also the Route 1 and Route 3 has higher population in the station district, mainly for Taipei. And for the accessibility, so human is easier to travel for the Route 1 and Route 3, because for the if you see the Route 1 is Taipei HSR station and Fuzhou South HSR South station, there are so many ways that people can go to there. And also the interchange and transfer, the Route 1 is the highest mark, so Route 1 is easier transportation from the station, and many routes they can choose to go to other place. And finally, it is the construction cost. As you can see, Route 2 and Route 4 has the higher mark, therefore the construction cost is cheaper. So by summarizing these marks and put it into the equation, the formula here, the total result is calculated. So after the calculation, we can conclude that the highest mark is Route 1, which is around 7.7 marks, and following the Route 3, and the third one is Route 4, and for the last one is Route 2. Therefore, after this scientific analysis, we can conclude that our result of station choose is from Taiwan is Taipei HSR station, and from the China side is Fuzhou South HSR railway station.
The next point is about the conceptual engineering.
So, we will beside the horizontal section to find the conceptual engineering. There are two possible developed railroad. We can see that the red one is from the Fuzhou to Hunan along East China Sea to Taipei. Another route is green color from Fuzhou to Pingyang along South China Sea to Taipei. We have to evaluate with screen criteria to select which one will be preferred route for our study. The following is the table, so that there have different criteria. There have a design criteria, constraint, environmental impacts, traffic, station access, horizontal, vertical, lead structure, O&M, then cost. By this criteria, we have a different rating for each criteria. We can see that in the table. And also, we have put different score from different route. From Pingyang, the design criteria is higher. And there are some criteria is the same. It's because the station is the same. By using this rating and this scores, we can find that the total score from Fuzhou to Pingyang along South China Sea to Taipei is higher cost, is 60. So we choose this route will be from Fuzhou to Taipei.
Another one is the vertical section analysis. Based on the railway routing from Fuzhou to Pingyang along South China Sea to Taipei, we allow studying the possible vertical section by analyzing the geographic feature. You can see that from this detailed mapping, in Fuzhou side that we suggest to build the high-speed railway along the existing road, because that in the construction cost that will be cheaper than to build it on some high mountain area. And along to Fuzhou to this side to the seaside, and the seaside that we are proposing to having a tunnel below the water So this one is we having this study and reading some information in Eurostar. So that's why we have this proposal. And in the Taiwan side, we are proposing having the food that near the existing train station. And because that the Taiwan high-speed railway station is also in a high location. Here is the Taiwan train station. And derived from the analysis on the mapping, we have this vertical section. And then from this vertical section, we can see that from the Fuzhou South station side, at the beginning, we are proposing to having some level crossing rail, and then from this leveling rail to the Fuzhou Beach. From the Fuzhou Beach, and then we'll downside to the Ping Tai, and then to Ping Tai, then we'll go to the tunnel side and then finally in the Taiwan here, we'll go through the Fuzhou Beach to the Taiwan HSR station. And also in this design, we are also very careful about the gradient, and which is less than 2% according to some information that the HSR should not that the gradient of the HSR should not more than 2%, and our maximum gradient is about 0.625%. And the below are the infrastructure type selection that we are having. The purpose of this selection is to define the general project footprint and provide baseline for preliminary capital cost estimation. There are 4 types of infrastructure that we're choosing. The first infrastructure is the Fuzhou Beach. It composed of different span and crossover the villa, the building, and crossover the existing road. And the second one is the leveling crossing rail. The third one is the retained cut rail, which is used to drop the HSR from the high side to the low side and to the sea level, to the level below the sea. The final one that is the tunnel. The tunnel is passed through. It's just a rail which is underground, and in our case it is under the water.
So the last part of this presentation is the capital cost estimation of this high-speed railway line. So for the capital cost estimation, this is our analysis result. And for after all the costs, adding up all the costs in different aspects, we have the total capital cost for this whole construction projects. So by breakdown of this analysis result, the details are here. Generally, the capital cost estimation, it can be divided into 8 aspects, as you can see in this table. And if you compare of this several aspects, you can see for the track structure and the track construction, the total cost is the largest one when compared to other aspects. It is because for some underwater construction for the tunnel between China and Taiwan side, the construction cost must be much higher than on the land. And besides this track structure, the second largest cost belongs to the site work, right of way, land, and existing improvement. Because in China, the infrastructure is not so good enough. Therefore, the site work need to be reconstructed. And also the land acquisition, the government need money for buy the land for building the high-speed railway station and viaduct, and also the underground construction. And among these two, for the third one is the station, terminal, and intermodal for the construction of high-speed railway station, and also the electric traction aspect. And The other one is the supporting facilities, which include the yard, shop, administration buildings, and also for some engineering aspect, it includes the communication and signaling facilities. For among these 7 type of aspects, the other is the belongs to the other costs. For the other costs, it includes so many things. For example, the professional service and also the contingency service. For the professional service, the many consultants will try to design the engineering and also the cost aspects for this project. And also for the contingency, we also need money for the maintenance costs and also the operation costs. Therefore, the total cost we calculate is around 22.2 billion of capital cost, and this capital cost is not include the train set at all. In this analysis, we will have some assumptions. For example, the total railway length is around 170 miles, and also after the calculation, we can conclude that the cost per mile is around 126 million US dollar. Compared with the normal capital cost per miles in around the world, 126 million US dollar is quite a reasonable price. Therefore, the analysis finally we think that it is reasonable. This is the end of our presentation. Thank you.